Hello, everyone, and today I'll be presenting our World Cup predictor for 2026, the World Cup held in America, USA, and Canada. This was made by me, Hugh Quigley, Josh Moore, and Aaron O'Shea. So, the features and factors for our World Cup predictor. There are four factors we use to predict the World Cup. We were using the ELO ratings for the teams, which are the internet, which we got from Kaggle, which are the international ELO ratings you can see there in the picture here. And then we also took the FIFA World Rankings, which you can see here, which are both displayed in the images there. And then we had two other factors, which are trophies won and semi-finals and finals reached in the last 25 years, and host nation advantage for USA, Mexico, and Canada. All of these are ranked in order of importance, going from ELO to world rankings to trophies, and then to the host nation. So why we used ELO and FIFA rankings because they're very similar. FIFA rankings some adjusts for match importance, so like it's friendlies versus World Cups, and it treats penalty shootouts as wins and losses. Whereas like traditional ELOs, they have like every game is counted, and like it penalizes knockout losses more heavily, and it takes into like goal factor and home factor, and it's more kind of accurate towards like how well a team is actually doing. So as we can see from some of our stats here, which have come from our thing, through the matrix, we can see how many teams we have, which is all 50 here. You can see the means and averages for like the ELO and everything there. And then you can see the top strength, the raw strength of each team. So Spain is top there, well, followed by Argentina, then France, then Brazil. And you can see the raw strength of the teams down here on the far right. And you can see we have the highest ELOs of each loaded here, which are obviously scraped from the Kaggle. And then you can see we used a Monte Carlo World Cup simulation. We did 100,000 iterations, took up to 6 minutes, and it shuffled the 50 teams, and all 50 teams actually won within the 100,000 thing. And it used obviously ELO, the FIFA points ratings, the trophy, and then the host. And then these are all the teams we used. We had to use some teams that haven't qualified yet, obviously, because there's still playoffs. So we added in some other teams such as like Ireland, Italy, and Ukraine, people that were just most likely to come through their qualifying group. Maybe a bit of bias there with Ireland. But then we also had to hard code some ELO in there because of the way the Kaggle had the names scripted that they couldn't be scraped. So we had to hard code in some of those as well. And now over to Josh.
So in this section, I'm going to walk through our two-stage pipeline. First, I'll run through how we trained our machine learning model to score each country's strength. Um, I'll then show how we use those strength scores in our Monte Carlo simulation, which predicts the World Cup winners. We ran into a couple of problems along the way, so I will go through each of our fixes for those problems. All right, so firstly, I'll show you our setup. So here are our libraries that we've imported. So we import pandas, which helps with our CSV files, NumPy for our matrices, LightGBM as our machine model or our learning model, Scikit-learn and its standard scaler, TQDM library for our process bars, progress bars. So let me just run that there. As you see, that runs fine there. We import our country ELOs, which is kind of like a combination of the players to give it like a bit of a score in comparison to all the other countries. Use our CSV file off Kaggle, which is called eloratings.cv, as you can see in here. We have this imported. Now, our first challenge was we were missing a handful of countries' ELO ratings from the CSV file. They solved this by combining two sources of ELO. One was the CSV file from Kaggle. The other one was we hard coded, as you can see, we hard coded a number of past year ELO ratings, so like December 2025 ELO ratings, to kind of compensate for the missing ELOs. You see here is where we combined those two sources, I suppose. So using .combine first, it checks first if the ELO is present in the CSV file, and if it is, it uses that. Else, it passes in our hard coded data. The next, we instead of having a purely ELO rating focused result, we include three other I suppose features or factors for the countries. So first we have our FIFA ratings. So this is the live 2026 official rankings off the FIFA website itself. Then counted up how many trophies each country has as kind of like a background to how well they've done per tournament. So some tournaments have higher weightings than others. So like let's say the World Cup will rank higher than the Euros. It'll give them a slightly bigger advantage. And lastly, we gave them a host bonus. So the three countries that are hosting the World Cup next year get a minimal 0.25% bonus, not percent, but score bonus. At the beginning, it gave an overly large bumping up, and that completely ruined our ranking. And the scores were all over the charts. So we brought this down to just a 0.25 bonus for the three countries, so for Canada, Mexico, and the US. But once we have our four features, which are the ELO ratings, FIFA rankings, trophy count, and host bonus, we can assemble them into a single data frame. Here we assemble our feature matrix, which is obviously the 50 countries that are taking part in the World Cup times the four features. Use a map function to match each country to its relevant feature value. Here you can see our final matrix at the bottom, the output. Um, you can see some of the statistics that just come with it, just the averages and of the ELO, 50 points trophy, whatever. And again, a snippet of the top 10 strongest teams, just based off the matrices. So again, as you can see, Spain, Argentina, France coming at the top with their raw scores being the highest. So that's a good sign for them, really. So now we're going to train a machine learning model. We're using LightGBM. It's it's fast and it handles small tabular data like CSV files very well, and allows us to see which features are most important. First, we need to create training labels. We do this by ranking the teams, as you can see, by their FIFA points, and then using an inverse weight. So what this does is it gets higher ranked teams with higher target values. See it with the output as Spain is ranked number one, it has a higher weight. And obviously, as you go down, lower teams gets lower weights. This is the labels that we're trying to teach the model to predict. We scale the features using our standard scalar library. This normalizes them so that they're all on the same scale. We then pass them into LightGBM with L2 loss, which tries to minimize the squared error between predicted and actual labels. Here is our model training setup. So as you can see, we keep it simple with only 200 boosting rounds and a small learning rate and a maximum depth of 5, as you can see here. The reason for this is it just prevents overfitting on our smallest data set. For the second stage, we file this data into our Monte Carlo simulation. We treat the World Cup as a knockout tournament and simulate it, as you can see right there. We simulate it 100,000 times. Each match, we calculate the probability that Team A beats Team B using a logistic formula based on their feature scores that we've obviously fed in from our training model. Here's our main simulation loop. So for each of the 100,000 tournaments, we shuffle all the teams randomly. We then, as like I said, treat it as a knockout. So we pair them up in a knock. We pair each team up in a knockout bracket and advance the winner of each match until only one team remains. So I'll run this here. It's take about 6 minutes. I'll skip forward to when it loads. As you can see, it is successfully loaded. It takes into account the ELO, 50 points, trophy count, and host bonuses, and has completed. Finally, we count how many wins each country has out of the 100,000, and we convert that into a percentage. Here's our final predictions. So as you can see, Spain comes out on top.
Showing the final predictions from 100,000 simulations. So first of all, our code will grab the four main features, which are the ELO rating, the team's FIFA points, their trophy count, as well as the host bonus. Also, it'll grab the probability of them winning from the data. Then it will convert the raw probability into a percentage chance of winning, which then it'll sort them from highest probability to lowest probability in the table, which will show now. So there we have the top 20 teams by simulation probability. We have Spain number one. They have a 16.59 percentage chance of winning. Their ELO is 2,171, and they have 1,877 FIFA points. In terms of feature validation, we're only using four features: the ELO, the clubs or team's FIFA points, the trophy count, and the host bonus. There's no extraneous features such as market price and goal difference, etc. And it is a clean single file implementation, so there's no external files needed. And then this is what creates the charts. First of all, we have the top 10 win counts. Spain are top with they have the most projected wins. And there's just a table of the odds.